Hi everyone. In this session, I am going to discuss about Introduction to Operational Amplifier. Myself, Pradosh Kumar, faculty from Department of Biomedical Engineering. Now we will be move on to the session. First, I will be discussing about an operational amplifier. So what is an operational amplifier? An operational amplifier is a direct coupled high gain amplifier. It consists of one or more differential amplifiers followed by a level translator and an output stage. It is a versatile device, that is, it can be used to amplify both AC as well as DC input signals. It is designed for computing mathematical functions such as subtraction, multiplication, integration, and differentiation. From the name itself, we can understand that the operation amplifier purpose is to do both the things. One is doing amplification of the given input signal, and also we can do multiple operations on a given signal. Can able to do addition, subtraction, multiplication, and so many different types of mathematical operations on a given signal. That's why it is called as an operation amplifier. In this case, we are going to study about the op amp, the operational amplifier. In short, we are calling it as op amp 741. We will be discussing about 741 operational amplifier. It has 8 pins. 741 IC integrated circuits has 8 pins. The first pin is used for offset null. Actually, what is meant by offset? First, we should know what is meant by offset. When a circuit without giving any input voltage, when we are getting the output from this IC, then that is called as the offset voltage. So what we are supposed to do, we need to nullify that output, that is called as offset null. So we have to null the offset voltage. Second pin is used for inverting input. So in that pin we have to give the inverting input, inverting terminal pin. Third one is used for non-inverting input, that is plus. Here we have to connect the non-inverting input. Fourth pin is used for power supply, that is for connecting negative power supply. See in this symbol there we have shown that fourth pin is for negative power supply, can be minus 15 volt. Fifth pin is used for offset null. The first pin and fifth pin both are used for the purpose of nullifying the offset voltage. Sixth pin is used as the output. So from the sixth pin we will be taking our output from the operational amplifier. Seventh pin is used for power supply. So this is the seventh pin, we are giving plus 15 volt positive power supply. So eighth pin is of no use, it is a no connection pin. So these are the role of each and every pin in this IC. So when when an IC is given to you, how will you find the first pin of the IC? For that you have to go from a anti-clockwise direction of this symbol, that is a symbol dot is indicated here, right? So from that you have to take an anti-clockwise direction, that is near to that is the first pin. So if we go from in anti-clockwise direction, that is this way like U shape, you can find the 8 pins in order. Okay, so this is about the pin diagram of IC 741. So another thing we should know is why we are calling this IC as 741, because we are giving 4 inputs to this IC, that is second pin is second pin and third pin acting as input. Similarly, this biasing voltage we are giving through this dual power supply, that is minus 15 and plus 15. So 4 pins are used for the purpose of giving the input. So 4 is coming, that's why 7, 4 and 4. 7 is used for the purpose of functionally active pins. Only 7 pins are functionally active. So we are using this 7 and 4 pins are for input and remaining one is the output, that is 1, 7, 4, 1, that is one output we are taking from this IC. That's why it is called as a 741 IC. Okay. Next we will move to the ideal characteristics of operational amplifier. So what are the ideal characteristics of op-amp? First, what is mean by ideal characteristics? That is, in an operational amplifier, the character, that is in case of a theoretical case, we are considering that to be an ideal case. Without any losses, we are calling that as ideal characteristics. So in the ideal characteristics of operational amplifier, the first point is infinite open loop gain. So what is meant by this infinite open loop gain? First we should know what is the open loop circuit. So IC741 open loop circuit means we are giving the input to IC741 from the second and third pin and we are taking the output from the sixth pin. But there will not be any feedback connected in this circuit. That is called as the open loop circuit. That is, feedback means output will be connected back to the input. In this circuit, there will not be any feedback given. That is why it is called as open loop circuit. So infinite open loop gain means the gain of the circuit, the gain of the circuit for an open loop circuit will be infinite. That is, when we are giving any input, the amplification will occur for an operational amplifier. That's why we are calling it an amplifier, operational amplifier, right? So when it is amplifying the input, the output from that we are getting output that will there will be an amplified value of the given input. That value amplified value will be very high, that is infinite for a open loop circuit. That is the reason we are calling a open loop gain is considered to be infinite. For ideal characteristics, we are considering that to be infinite. But actually, in case of the closed loop, in case of the practical circuit, the gain will not be infinite. Practically, it is considered to be 2 into 10 power 5 for a 741 IC. Open loop gain is considered to be 2 into 10 power 5 for a 741 IC. So the next point is about infinite input impedance. So the input impedance is infinite. Infinite input impedance of an operational amplifier 741 IC has to be infinite. This is for any op-amp. Actually we are studying ideal characteristics and I am specifying telling about the 741 for a practical case. For input impedance for an op-amp is considered to be infinite. That is, usually for an operational amplifier we are considering the input value should be very high. For since it is an ideal characteristic, we are considering that to be infinite, so that we will not get the problem of loading. Whatever input we are giving, that value will that input will be properly amplified and will be getting the output, so that the infinite input impedance should be infinite for that. So next point is output impedance, that should be zero output impedance. So what is the advantage of zero output impedance? Mean when any output is coming from our op-amp, then that value will not get loading, will not have any loading effect, so that the entire value will be utilized for the load. That's why the output impedance should be 0. And the next point is bandwidth. How the bandwidth should be for an operational amplifier? It should be infinite. That is, the bandwidth should be very high. So bandwidth is considered to be the, what is the meaning of bandwidth? The range of frequencies for which gain is considered to be maximum. So that we are expecting to be infinite. Usually we expect for a circuit the bandwidth should be very high, infinite. Okay. So next thing is offset. What should be the expectation for offset for an op-amp? It should be 0. That is, without giving any input, we don't want any output voltage for this ICs, for this op-amp. So we should have a 0 offset. That is, output should be 0 when input is 0. That is the meaning of our V0 equal to 0 when V1 equal to V2 equal to 0. When input voltage 0, our output also should be 0. And the next point is CMRR. What is CMRR? Common mode rejection ratio. This is that is the common mode signals for a operational amplifier should be rejected. Only we want the signal amplification should be for a difference in signals. We should not have any amplification of common signals. So that case, we expect our common mode rejection ratio CMRR to be infinite. That is, the value should be very high. Okay. So that is common mode rejection rate. How much we are expecting the rejection to happen means common mode signal rejection should be very high. That is infinite for ideal characteristics. And the last point is slew rate. What is the expectation for slew rate? Means infinite value. What is meant by slew rate? Slew rate is nothing but the rate of change of output voltage for change in time. That is d by dt of voltage, output voltage. So the output rate of change of output voltage with respect to time should be very high, infinite Vrx. That is, for a small change in input also we should feel the output change. So that is nothing but slew rate. So we expect our circuit to be very high slew rate. That is the infinite slew rate. So this is a very important thing about the these are the very important things about the characteristics of op-amp, ideal characteristics of operational amplifier. Thank you.